Hello, friend. My name is Derek Harder, and in this video, we're going to continue looking at application programming development using Python. So, in this one, this is our first look at what our textbook calls decision structures. So, there's ways to put in code in any kind of programming language in order to do more complicated things than just executing instructions in a sequence, right? So for a decision structure is basically depending on if something is true or not, we will only execute some statements if something is true, and if it's false, we might execute some different statements. So we'll look at that, and we'll look at doing some nested decision structures and other slightly more complex ideas of decision structures in this video. Okay, so if you're ready, let's go ahead and get started then. Okay, so the first decision control structure we'll look at is the basic if statement. Okay, so an if statement is used to create a decision structure which allows a program to have more than one path of execution. Okay, so up to this point in this course, you've only seen examples of what we would call a sequence structure or sequential execution, where there's a set of statements or expressions and we execute the first one, then the next one, the next one. So a decision structure like an if statement or an if-else statement has specific actions that are only performed if some condition exists. Okay, so we're going to test if something is true or not, and only if it's true will we execute the statements that are specified by that decision structure. Okay, so these are also known as selection structures. In other programming languages, you might have other things than if-else statements, so switch statements and some other things. But Python basically just has an if-else statement for making decision structures. So the if statement in Python looks basically like this over here. So if something is true, so only if the condition is true will we execute one or more statements, so one or more Python expressions like we looked at in previous videos. Okay, so actions can be conditionally executed. We only perform these actions, these statements, when the condition is true. In Python, I think we've talked about this a little bit before, but this is known as a block of statements. And in Python, blocks are identified using indentation. Okay, so many other languages use a special character to indicate a block. So most C-derived languages use open and closing curly braces to denote a block of statement. But in Python, it's different than most other languages you might be familiar with. You actually have to use indentation to indicate a block. And the indentation has to be consistent. So I might talk about that more about that later. But in this class, you should always use 4 spaces for every level of indentation whenever you're forming these blocks like this for like a decision structure. So the most basic is that the single alternative decision structure provided by an if statement, which is just one alternative path. So if the condition is true, we'll execute these statements. If it's not true, we will jump over these and execute the next statement after the end of this if statement. Okay, so this first line is known as the if clause, and it includes the keyword if followed by a condition, and we'll see some more examples of what constitutes a condition. But basically, it has to be Boolean. It has to be either true or false for this kind of if statement. So our textbook uses flowcharts to visually illustrate a lot of these concepts that we go over. So a if statement in a flowchart form would be diagrammed like this, where we use this kind of diamond, and there's going to be 2 paths coming out, the true and the false path. So for a simple if statement, if the condition is true, so if it's cold outside, we would execute these particular statements. So just as a real quick example to make this concrete, the previous flowchart might look something like this, right? So here's our first example of a Boolean expression. So I'm defining cold to be anytime the temperature is less than 32 degrees. So if it's cold, so if the temperature is less than 32 degrees, we're going to do these statements. So all these statements are indented by 4 spaces. So these form a block. So if that condition is true, it will execute these statements. And the statements here can be other things than print statements, but we're just using print statements here. So, but if we run this, it's true right now that the temperature is less than 32, so it prints these out. And if the temperature is greater than that, let's say it's 35, and we run it, you won't see anything else, right? So basically, in either case, whether it executes these statements or not, after it's done, it will then continue executing sequentially after the if statement. So this print statement should get executed in both cases, right? So even though the temperature is not cold, we jump over that and print that out. But when the temperature is cold and we execute that, it actually executes these statements, and then it continues on after that with the print statement. So a little bit more about those statements, the conditions that are checked. So we'll use what are known as a Boolean expression, and the most common way to create a Boolean expression is to use relational operators. Okay, so Boolean expression is an expression that's tested by the if statement to determine if it's true or false, and then these relational operators, greater than, less than, equal to, are the most basic kinds of Boolean expressions that you can define. Okay, so the relational operator determines whether a specific relationship exists between two values. You know, example, one value is greater than, or in our example, we were using less than. So one value is less than another value. Okay, so the complete list of the Boolean expression, the relational operators that are available to create Boolean expressions are these in Python. And most programming languages, pretty much they have these as the basic relational operators. So you can have strictly greater than, strictly less than, you have greater than or equal to, less than or equal to, and then for testing if things are equal or not equal, you use two equals. So remember, a single equal sign means assignment in Python, as well as many other programming languages. So we use two equals if we want to make a relational test if two values are equal or not. And also the exclamation mark is used in many programming languages to mean not. So this is usually just read by most programmers as not equal to. X is not equal to Y. I just wanted to quickly emphasize a common mistake that people do make when comparing if two things are equal or not is to forget, right? So you know, back to what what I was talking about, the equal with a single equal sign is for assignment. So this isn't a relational comparison whether these two things are equal or not anymore. And you'll see that this is an error. So if I try and run this, we should get some kind of syntax error from Python that this is invalid syntax, right? So if I want to check if two things are strictly equal, I need the two equal signs. So this is actually a Boolean comparison that they're equal or not. Right? So it should only be true if the two things are exactly the same. So there we see that they were the same, and it actually executed these three statements that were part of the if block. Okay, and just a little bit more about Boolean expressions and relational operators. So any relational operator can be used in the decision portion of the if statement, so in the decision block. So, you know, we already saw, you know, testing if two things are equal, or testing if two things are not equal, or any of the other relational operators. It is possible to have blocks of statements inside of another block. So you can have if statements inside of functions, which will be a topic coming up in another week or two, or later on. So we'll have more about this later on in this video, but you can have statements in inner blocks with respect to outer blocks. So you could have actually nested decision structures or nested blocks. So it is often common that if you're using one of these if statements, checking a condition, you want to do something if the condition is true, but when the condition is not true, there's other things you want to do instead, right? So an if-else block, and our textbook calls this an alternative decision structure, only executes the statements if the condition is true after the if in the if block. If the condition is false, if it's not true, instead it executes these statements. And in either case, it'll either execute these first statements or these second statements depending on the condition that's tested. And once it's done with those, it will then continue executing the statements after the end of the if-else block. Okay? So visually, a flowchart representation of this alternative decision structure would look like this. So again, we have the diamond for the flowchart, but both paths for the true and the false have some one or more statements that are executed. So if it's true the temperature is less than 40, we would do this, and if it's false the temperature is less than 40, we would do this here. So as a quick example of a working if-else alternative decision structure, so here, if we're testing still weather is less than 32 degrees, so if the temperature is less than 32 degrees, it should do these portions, and if it's greater than 32 degrees, it should do these the portions of the else. Okay, I maybe forgot to mention before, so also part of the syntax you shouldn't forget is that there is a colon at the end. So for the if portion, you have some sort of a condition, so some sort of Boolean expression, and then there's always a colon at the end before the block of statements to be executed for that condition, right? And the same for the else. There should be a colon after the else, and then a block of statements that are executed if this condition was false. Okay? So in this case, you should be able to predict what's going to happen here. So since the temperature is less than that, I would predict that if the temperature is less than that, here's a common mistake. So I was confusing myself, but don't forget this is when you're running an interpreter, you do have to save changes. I hadn't saved my changes here, so let me save my file there. So now it should work the way I expect. So right, so if the temperature is less than that, it does the if portion, so we get all these statements printed out, including also then when it's done, it prints this statement out there. But if the temperature is a little bit warmer than that, it should do the alternative portion. So it should do the else portion in there. So just to reiterate, I think I covered these points already, but the basic idea of this if-else statement, the alternative condition statement, is that, you know, if the condition is true, the statements after the if, after the colon in the block here will get executed. Once it executes these statements, it jumps over this and starts sequentially executing statements after the if-else block. Excuse me. If the condition is false, instead it won't execute these. It will jump to the statements in the else portion and execute those. And once it executes all those, it will continue executing the statements after the if-else block. And Python indentation is used to indicate blocks of code. So the statements in each must be indented consistently and correctly in order to be correct for the syntax that Python is expecting to recognize the if-else statement and the block of code that's to be done if the if is true, and the block of code that's to be done if that condition is false. So in Python, you can compare strings, and it will do basically probably what you would expect it to do. So you can use the equals or not equals to compare whether two strings are equal to each other or not, right? So if I have a string Mary and Mark, it's not true that these are equal, but it is true that they're not equal. Okay? And, you know, kind of, it's a little bit more complicated than this, but basically, if you remember, we talked a little bit about the ASCII encoding of characters in a string. It's really comparing the characters, right? So for strictly equal, every one of the ASCII characters in two strings would have to be equal for it to return true, that the strings are equal. But so we mentioned this because basically also comparisons like less than greater than actually work. It'll give you an alphabetical sorting or an alphabetical comparison. So if Mary appears in the alphabetically before Mark, it would be true that Mary would be less than, but actually Mark should alphabetically come before Mary. So it's true that Mark is less than Mary, and it's false that Mary is less than Mark. And you can use less than, greater than, or the other comparisons if you need to sort or compare things. So, and kind of also just a little bit of a detail on this. You know, the ASCII character for uppercase and lowercase is different. So if you don't do anything special, it will sort. So I believe that capital letters come before lowercase letters, right? So if we had like a capital Mary and a small case Mark, Mary would always come before Mark alphabetically. Okay? We'll talk more about. We'll have more examples of more complex things you can do with strings later on in the course. Okay, but keep that in mind. But yeah, just a real quick example of this working. This is one of the examples from the textbook. So if we enter a password, let's say Caliban. So in this case, Caliban is not equal to the password that was trying to be tested here. So we will get the, so this is not true, so we get the else portion of the statement. So if we give the correct password, where those are equal, we'll get the if portion statements executed here. Also, another quick example talking about, alphabetical ordering of strings. So here, if we do the example from the textbook where we enter Mary and Mark, it will place Mark before Mary. So it's checking, it's seeing that Mary is not less than Mark. So we end up printing the second name that I entered. Right? And like I said, if we do that, and if we use Mary, but I use Mark with a lowercase, uppercase should come before lowercase. I believe, hopefully I'm correct about that. Let's check it out. So, right. So anything uppercase M would come before all the lowercase m's when we're sorting alphabetically here like this. Okay, and then finally, a little bit more about some more complex things that you will need to be able to do for this class here. So it's common that we need to test more than one condition in a decision structure, right? So one way you could do that is you could actually nest decision structures, okay? So let's say you're trying to write a piece of code in order to determine whether a loan should be, whether somebody qualifies for a loan or not. So in this case, let's say there's two conditions to qualify for the loan. You have to earn at least $30,000 a year, and you have to have been employed for at least 2 years, okay? So one way we could do that is to nest conditions. So we could check the first one, and if that's true, then we check the second one. So the way you would do the nesting, like we just described, would look something like this, right? So we would first check, here's an example of nesting an if-else block inside of this if-else block here, right? So we first check if the salary is large enough to approve the loan. Only if that's true, then we make our second check to check that they've been on the job for 2 years, right? So if both of those are true, they qualify for the loan. If either one of those is not true, so if it's true that they make the right enough salary, but they haven't been working long enough, we will get this message printed out. And if it's not true they make enough salary, we would instead get this message printed out, right? So I'll only do maybe one where both of them are true here as an example. So if we run this, loan qualifier, first version, so if our salary is big enough and we've been employed long enough, we should end up, this is true, so we go into the if portion of the block, and then we do a second nested check, and this is also true, so we'll do this. And then after we do this, we jump to here, and then when we're done with our if portion, we jump, we're not going to do these things else, and we would be doing code after the outer if else in this nested block here. Okay? So we'll probably talk more about this in this course here, but often when you do nesting, multiple nested structures like this are considered hard to read and understand. It's not just considered, I mean, it is true. So there have been scientific studies on this. So the more nesting you have, the more complex it is to understand what is going to happen when you look at a piece of code. So it's often considered bad form to be nested 2, 3. It's definitely considered bad form, and you need to refactor your code if you have more than 3 or 4 levels of nesting in code here. So one thing you could do is you can have a more complex Boolean expression. We're going to talk about this in the next video here. So since there's actually really 2 things that have to be true, we could have just used an and statement. So here, if it's true that both the salary is greater than the minimum salary and we've been on the job more than the minimum number of years, then they qualify for the loan. Okay? So that would be one way that we could reduce that nesting and get it back to only a single level of nesting here. Okay, and just to be complete here about the nested structure here. So, you can also represent nested structures as a flowchart. So it would look something like this, right? So the same before, where we use the diamond in the flowchart to represent the if-else decision structure, but we're going to be nesting a second test for the if-else structure where we're testing the years on the job. Okay. And then finally, in this video, so it's often the case that we need to check things that are really conceptually more than a Boolean true or false, right? So a common thing is that we need to do something if a value is in one particular range, and do something else if it's in a second range, and something else in a third range, and so on. So this is our textbook calls this a multi-way decision structure. So it's common to have this kind of a decision structure in most programming languages. So in Python, it's an if, else if, else if, else block of statements that you can use for this multi-way decision structure. So, so for example, if we needed to have a piece of code to do something depending on the grades in a class, where if you have 90 or above, you get an A. If you have between 80 and 90, you get a B. This might be implemented as a bunch of nested control if-else control structures. Okay, so this flowchart is really indicating a nested structure. So that would look something like this in code here, right? But again, this would be considered bad style here, right? So it gets more and more complex the more nested you have. This would work. So if the score was bigger than 90, it's an A. If it's less than 90, we're going to be down in the else. So in this point, we know it's less than 90. So if it's bigger than 80 and less than 90, it's going to be a B, right? And if that's not true, we continue on with the rest of the things, right? But instead, you really should use an if-else-if statement so that you avoid that multiple nesting. So that same block of code should more correctly be implemented like this, using a multi-way if-else-if structure, right? So if the score is greater than 90, it's an A. Otherwise, we're going to be testing the other thing. So to get past this, it's not bigger than 90. So if it's true that it's bigger than 80, though, it must be between 80 and 90. So in that case, it's a B. And if neither of those is true, it's not bigger than 90. Also know it's not bigger than 80. So it has to be less than 80. But if it's greater than 70 and less than 80, that's a C, and then so on. Okay. So we can run that real quickly just to show that it works. The greater else if. So if you get a 66, it should jump. So it's not true that it's greater than 90, it's not greater than 80, it's not greater than 70, but here's greater than 60. So it ends up stopping at this point, right? And if none of those are true, so the final else that I didn't mention yet happens if none of these are true, right? So if you have a final else where you don't specify a condition, it will print that out, right? So it has to be the case that my grade was not bigger than any of these in order to get down to the final else statement. So just to summarize what we learned in this video. So we looked at the basic conditional statement available in Python, the if decision structure. So you use the if decision structure to conditionally execute some statements only if a condition is true. We'll have a little bit more about Boolean comparisons and relational operations in the next video and throughout this course. The basic Boolean comparisons that you would use for the decision that you make in an if statement like this are things like less than or greater than or equal to. You can compare if things are equal or not equal to using double equals for the equal to, or the exclamation equal, the bang equal for the not equal to. So beyond a basic if, so it's common to need to do some things if the condition is true, but do some other things if the condition is false. So you would use an if-else alternative decision structure in that case. And you can nest these. So you know, in this course, you'll need to do even more complex things than that. So you can use a nested condition. Although, as I'm hinting at, it's usually not a good idea to have multiple nested if conditions. So we'll look at, in the next video, at you really should probably be using a more complex Boolean expression, or maybe something like a multi-way if else decision structure, if you have a more complex decision that you're making. Okay, so I hope that was useful. That's it for this video. So join me for the next video where we'll get into some more complex decision Boolean expressions you can make and some other topics. So I hope to see you in the next video or in class.